Let's take a look at example 2 of U-substitution. We have the antiderivative of x over the square root of 2x minus 1 dx. I want to go ahead and talk about, again, how to figure out what your u is, which is the most students find the most challenging of U-substitution. Again, this would be impossible to do without U-substitution. We cannot use a regular antiderivative rule to figure this out. So how do you figure out your u? Well, again, 9 times out of 10, it's going to be whatever is inside of another function. So we can see that this 2x minus 1 is inside of a radical. Okay, square root of x is a different function than 2x minus 1, which is a linear function. So it's a function inside of a function or function composition. That's going to be what your u is. Now, in this case, you might think, okay, well, the derivative of 2x minus 1 is 2. We want that 2 to cancel with something else in our function, and it's not going to in this case, but that's all right. Remember, this x can be replaced in terms of u. Since u is going to be 2x minus 1, we can get x by itself and make it work. So it won't always cancel with something else in the function, but if we can see in advance that we can get x by itself in terms of u, then it should work. So again, the main hint, though, is it's usually a function inside of a function, in this case 2x minus 1 inside of the square root. So for step 1, our u is going to be equal to 2x minus 1, which is inside the radical. Step 2, we're going to take the derivative of that, d dx of the entire thing, and then d dx of u is just du dx, and then the derivative of 2x minus 1 is just 2. For step 3, we're going to get dx by itself. A lot of times you do cross multiply, so in this case, since dx is on the bottom of du, cross multiply, so you're going to get 2 dx is equal to du. Divide both sides by 2, and you have dx by itself. It's equal to du over 2. And again, we're doing that because when we go to take the antiderivative, everything has to be in terms of u, including this dx. Step 4, replace the expression by u and dx in terms of du. So our u was 2x minus 1, so 2x minus 1 is going to be replaced by u, and our dx we just figured out is equal to du over 2. So it's going to be replaced by du over 2. Now this leads us to one of those steps that we didn't use last time. We still have an x. We cannot take the antiderivative of this because there's an x here. Fortunately, we can get that x by itself. Now step 5 is to simplify. So what I did was I just used basically the idea that there's a 2 here. I moved it out front and made it 1/2. So it's 1/2 times the antiderivative of x over the square root of u du. So this does lead us to step 6. We cannot have an x. Everything has to be in terms of u to take the antiderivative. So we already said that u is equal to 2x minus 1. So for step 6, we're going to replace the remaining x's in terms of u if necessary. So we're going to get x by itself in our u equation. We're going to add 1, divide by 2. X is equal to u plus 1 over 2. So guess what? This x can be replaced by u with u plus 1 over 2. So now everything's in terms of u, right? Now, we can't really take the antiderivative of this yet, so we're going to have to simplify this even further. But the point, again, of this step is to get rid of any remaining x's and just replace them in terms of u, which we've done. Step 7, ensure that the remaining expression is antidifferentiable, so we're going to have to simplify this even further. So basically what I did was I took the top of this, okay, and I'm just going to multiply it by 1 over square root of u, because it's the same as dividing by square root of u. And then from there, now we can just multiply these two things on the bottom together in the top, so it's going to be u plus 1 over 2 square root of u. And then from there, since I just have one expression on the bottom, I can divide each expression on the top by 2 square root of u. In order to do that, I'm going to change that to u to the 1/2, knowing that this is u to the first on top. And I can also take this 2 on the bottom of the fraction, move it out front, so it'd be 1/2 times 1/2, which is 1/4. So that's what happens with the 2 there. And then u to the first divided by u to the 1/2 is just u to the is going to be u to the 1/2, and I have to take the 1 and also divide it by u to the 1/2. So over here we're going to have u to the 1/2, and then 1 over u to the 1/2, I can basically turn that to a negative exponent. It's going to become u to the negative 1/2. So now we have 1/4 out front times the antiderivative of u to the 1/2 plus u to the negative 1/2 du. And now I can take the antiderivative of this because I can use the power rule for u to the 1/2 to take the antiderivative. I can use the power rule of u to the negative 1/2, or the reverse power rule, rather, for the antiderivative. So that completes step 7, which is to ensure that I can take the remaining, the antiderivative of the remaining expression. So step 8, now we're going to take the antiderivative. We're going to have that basically the 1/4 is just going to be pulled out to the front, and we're going to just include it in our final answer. Again, to take the antiderivative of each of these, we're going to use the reverse power rule, meaning you add 1 and then divide by the whatever that you get. So 1/2 plus 1 is 3/2. We're going to divide that by 3/2. If you add 1 to this, you get 1/2. So we're dividing that by 1/2. So it'll be u to the 1/2 plus 1. So it'll be u to the 3/2 over 3/2 on the left, and u to the 1/2 divided by 1/2 on the right. Again, don't forget your 1/4. This will simplify to 2/3 u to the 3/2, and this will simplify to 2 u to the 1/2. Don't forget your plus c, and then you can just distribute this 1/4 back in. So you're going to get 1/6 u to the 3/2 plus 1/2 u to the 1/2 plus c. And again, that's 1/6 because it's 2 over 12, which is 1/6. Okay, and then finally we can just substitute whatever u is equal to in terms of x. We said u is equal to 2x minus 1. And then that is going to be your antiderivative. You can check by taking the derivative, and you will get the original.